Hi everybody, this is John Walker, your physical science teacher, and we're going to talk a little bit about magnets. Now, I know you know quite a bit about this, so this is going to be a little bit redundant, but still pretty interesting. So magnets are found in many things like telephones, doorbells, electric can openers, and electric motors. They are also used to run special high-speed trains. Over in Japan, they do it all the time. And for high-energy particle research. What is the big attraction? High-speed trains go as fast as 400 miles per hour with the manipulation of magnetic force. And once again, it's over in Japan. Okay? You can see that. Look at that. Magnetism is the force of attraction or repulsion by magnetic materials. Magnetic materials include the elements of iron, nickel, cobalt, and objects made of steel. Notice these are all metals, aren't they? They're all metals. Each end of the magnet is called a magnetic pole. Every magnet has a north pole and a south pole. So does our Earth, huh? The north pole of a bar magnet will point in the north direction if hung on a string. Even if magnets broke into many pieces, each individual piece would have a north pole and a south pole. Did you know that? That's pretty cool anyway. So this is what a lot of the of the travelers back in the 300 years ago, and the ships when they were on the ocean, they used the magnets to find the direction of where they were going, north and south. Properties of a magnet. Like electrical charges, opposite poles of any two magnets will always attract each other. Like poles will repel. Okay, so here's that. Electrostatic forces. Like charges repel. They go in the opposite direction. Opposite charges attract. Okay, same thing. Magnetic forces. Okay, you see the two ends down there. Okay, north versus south. The two ends are going to repel each other, and if you have a north and a south, they're going to attract each other. Magnetic field and region of magnetic force that surrounds a magnet. Different magnets have different magnetic fields because some magnets are stronger than others, and a weak magnetic field may not have the same magnetic field as a strong magnet. Okay, so lines that show the shape of a magnetic field are magnetic lines of force. That makes sense, doesn't it? Okay, so here are the magnetic lines of force. Okay, South Pole, North Pole. Okay, lines of force always begin at one pole and end at the opposite pole. The lines are closest together at the poles because the magnetic field is the stronger at the poles. Groups of atoms whose magnetic poles are all lined up in the same direction create magnetic domains. Domains, kind of a good name for a whole bunch of of an area. The north pole of each atom points in the same direction, and in the south pole, each atom points in the same direction. Naturally occurring magnets. The magnet found on Earth is magnetite. Magnetite. Magnetic induction is the process of making the domains within certain materials point in the same direction. Rubbing objects made of alloys of iron, nickel, and cobalt are easy to magnetize with a magnet. Have you ever done that? Pretty cool, actually. A temporary magnet is a material that is easily magnetized, but it tends to lose its magnetism quickly. Materials that are hard to magnetize can stay magnetized for a long time and are called permanent magnets. And we use them every day in construction and building and science and everything like that. All magnets, even permanent magnets, can lose their magnetism. Okay. Dropping a magnet can cause the domains to stop pointing in the same direction. Heating a magnet can cause the atoms to move faster and further apart, also misaligning magnetic domains. And that's the end of our magnets, our magnet discussion. I'll have some further information on it, but you can read about it in the chapter on magnetism, and I'll probably have a couple of more videos on this. Talk to you soon.